Okay, I'd like to talk about Newton's third law of motion. Newton's third law states that when an object exerts a force on another object, the second object exerts an equal and opposite force backward on the first object. What this means is that forces always come in pairs, and the direction of force is always equal and in opposite directions. This means that they have equal magnitude, and so they're equal and opposite. If you take a look at this picture, you have an object sitting on a table, and gravity is obviously exerting a downward force on the object. So the object is pushing down or pulling down on the table, but the table is also exerting an equal and opposite force on the object. This could be a book or a brick, but the forces between the object and the table are equal in magnitude, and they're in opposite directions. Imagine if the force from the table were less than the force from the book, then the book would accelerate downward. So if the table ever ceases to exert a force on the book in an upward direction that is at least as much as the downward force from the book, then you'll have a change in motion, you'll have an acceleration. Consider if I pushed really hard on this wall. I would exert a force on the wall, but the wall would also exert a force back on me. And it would be in a magnitude exactly equal to how hard I was pushing. So the forces would be in equal magnitude. Imagine if you punched the wall. The reason why your hand would hurt is because the wall exerted a force backward on your hand in the same magnitude as you exerted on the wall. So there are equal paired forces there between your hand and the wall. Consider a baseball player hitting a baseball. The force between the bat and the ball are equal and in opposite directions. But consider this question: why is it that the ball accelerates so much more than the bat? The bat's motion doesn't change very much at all, but the ball's motion changes dramatically, which means it has a large acceleration. The reason why these accelerate so differently, even though the forces between them are equal, is because of Newton's second law. If you'll remember, Newton's second law of motion says that force equals mass times acceleration. So what's the difference between the bat and the ball? Well, the mass is very, very different. The ball has a very small mass, and the bat has a very large mass, because really the bat is connected to the baseball player because he's holding it very tightly, and the player is even connected to the ground because he's, through friction, kind of stuck to the ground. So the bat takes on the mass really of almost the whole earth, and the ball does not because it's flying through the air. So if you were to do a force equals mass times acceleration calculation and you plug in the mass of the ball using the force, you would get a very large acceleration. That same force applied against the mass of the bat, the player, and the whole earth gives you a very small acceleration, which means it's a very small change in motion. And that's why the ball accelerates so much more than the bat. But keep in mind, because of Newton's third law, which is always true, the forces on the ball and on the bat are exactly the same.